Sir.
Yes, good evening. We can hear you.
Okay. Okay, so we'll just move to our sessions. So today mainly we are here to know about the Civil 3D software and what are the things can be done in Civil 3D, how the BIM integration with Civil 3D, almost the brief idea about this. So we'll start now. So Civil 3D, basically, as you know, we will be using for the infrastructure project. So in today's demo sessions mainly about introduction to the Autodesk Civil 3D for design, analysis and documentation of civil infrastructure project. So my name is Ms. Prajana. I'm the Chief Trainer in SPS Training and BIM Institute. So we are giving training almost all the BIM related software, engineering and construction related software, all the Autodesk and the Bentley softwares. We are doing not only the Autodesk and Bentley software, apart from that the Rhino, Grasshopper, like visual programming. Mainly we concentrate on engineering and designing. Apart from that we have the finance, HR courses as well. So today we are going to mainly discuss about the Civil 3D software. So basically Civil 3D is a civil engineering design software. You can use this one. We normally use this for the infrastructure projects such as road, and highways, land department, railways, airport, water system, utilities. Civil 3D is one of the software from Autodesk. Autodesk is having many software, like you know that AutoCAD, Revit, like many other software. So many softwares are there from the Autodesk. Civil 3D is mainly for the infrastructure project, and Civil 3D is the software. Actually, it's almost same like CAD software, but it has an added options for infrastructural. Yes, it has an added features for infrastructural background, like you know the earthwork, and you can do over the corridor, the road creations. Mainly we do with corridor. You can create the profiles over here. You can create the sections over there, and you can do the plan productions over there. You can take the quantities. You can take the the document, the analysis, all these things you can do it. So this is not AutoCAD. It's the platform is almost similar to the AutoCAD. You can see in my screen, it is almost similar to the AutoCAD. Everything looks like AutoCAD, but this is not really limited to the AutoCAD. We have more tools which is emphasized on the infrastructure related work. So anyway, so that is the Civil 3D software, and in the Civil 3D mainly we have how we work on the Civil 3D, or what is the key capabilities of Civil 3D. The first one is survey and terrain modeling. That means you will be having the survey data or the points or the GIS informations, whatever. You have the coordinates, you have the points. Based on these points you can create the accurate surfaces here. So basically this is a 3D. Civil 3D is basically a 3D software. So you import your model, you import your points. Based on that point, you can create over here the surfaces. Then once you create the surfaces, you can do the alignments over there, you can do the profiles over there, and later on the corridor and road design you can do it, and you can create the grading surfaces, and you can do the earthwork calculations like cut and fill values, you can take it from there. And when it comes to the piping, you have the utilities like stormwater, sanitary sewer, pressure network, all these things that's coming under the pressure pipe networks and utilities. And you will be having the plan productions and documentation. So these 6 steps are the main or important features of the civil 3D. The first one, the survey and the terrain modeling in the sense surface creations, alignment and profile, corridor and road design, then grading and earthwork, pipe network and utilities. Then you can see the plan production. So anyway, we'll go to the model now. I'll just open one file. So normally how we create the surfaces over here. So basically you will be having the point. Based on that point, you need to do the surfaces here. So these points you will be getting as a survey points. So that means you will be having the XYZ coordinates of your points. You take that points, then based on that points you can create the surfaces. So that is the first step. Then based on the surfaces only we will be doing the remaining all. So normal process, let's say if you want to create the surfaces, and you can see here in the Civil 3D software, normally some tools you can see here, draw, modify, layers, this is same like AutoCAD, but you can see over here this is which is emphasized on the infrastructural work. Like you can see the ground data, and you can see the create design. Here we create the feature line, grading, parcels, etc. So normally the first step, you need to import your points over here, then you have to create the surface out of these points. So I'll simply showing you here. Let's say suppose I need to create the surface. I'll just give here EG, then we click OK. So you can see the surface is created over here with the name EG. Then I have to take the point into the surface to create the surface. So currently I don't have any surface here. I have to create the surfaces. To create the surfaces, I should have the points. Point in the form of text file or CSV file or just data, or even AutoCAD contour lines, you can select it, anything. So currently I'm selecting the points. So when you select points, the surface will be created over here. I have to add the points data, and when you add the point, actually I'm selecting this point here. Normally we have the different point specifications over here. That means NEZ space delimited, XYZ LIDAR classification, PNZ, that means point, easting, northing, and the Z value. So currently the file what I have selected, that is PENZD, that means point, easting, northing, Z value, and the elevations will be there. That means the elevations and descriptions is point number, easting, northing, point elevations and descriptions. Then we click here OK. See here, now I select that point, my surface is created. This is my surface now. This is my terrain. So basically in Civil 3D, everything we do based on this terrain. This is my terrain, or you can say as surfaces, whatever. So based on the surfaces, we will be doing all the other things. That means this is your basic surface. Then on the surface we will be creating the road network. We will be creating the to create the road network, you have to create first profile. To create the profile, you have to do the alignment. So anyway, everything will be based on your surfaces. So I'll just open one file. So this is already a created file. You can see this is the surface. This is the first process. As I said before, you have to select the points and you need to create the surfaces. After you created the surfaces, the next process is we have to create the alignment. You see here this red color line, which is called the alignment. So basically alignment means your let's say this is our road, okay, we created over here the road. So alignment will be, normally we consider as a center of the road, but there is a cases we'll select the alignment as a left side of the road, right side of the road. That means not always center alignment, sometimes it will be left, sometimes it will be right, but currently we have used over here as a center line of the road. So then once you create this alignment, so normally you have the features over here for the alignments. So once you create the alignment, then the next process you have to create over here okay, once you create the alignment, then the next process you have to create the surface profile. So you can see here, let's say I'll just check what is the name of my alignment. You keep the mouse pointer here, you can see the alignment name. This is name is center of 1. So I select this alignment center 1. Yeah, this is the right side one, this is the center one, this is the one. And here you can see two lines. You can see one line here and another line here. So one is basically the surface, you can see that one, this is the layout and this is the surface. So there are two types of profile. One is your surface profile, the other one is your design profile. Surface profile in the sense, through this, currently I have placed the alignment here. Through that alignment, how your surface will be look. Let's say you cut your surface through that alignment, how the alignment will be looks like. That means you can call it as a profile, or you can call it as a vertical alignment, you can call anything. So that will be created from your surfaces. So whatever the surface you select, from the surface directly it will be created. But the other one, you have to create it yourself. That means for the design purpose, maybe you will be having the points, based on the point you have to create it, or you have an CAD lines, based on the CAD line you need to create it. That means the layout profile is the profile what you are using. This is your finished grade profile, and this is your surface profile. That means when you create the corridor, you will be creating the corridor based on this layout profile, not the surface profile, because surface profile according to your surfaces, then we will be creating the corridor based on our design profile. So you will be having two profile. One profile is automatically creating based on your surfaces, and the other profile is you have to create it. So once you've done that, then you can see the corridor. Let's say this is your, let's say I'll select this surface, maybe this is the corridor surface. When you go to the object viewer, you can see how that surfaces looks like. See that corridor, the surface is created according to the the corridor is created. From the corridor we have created the surfaces. So normally how the corridor is creating, to create the corridor you should have an assembly. So this is currently my assembly for this one. So you can create the different kinds of assembly. It's called sub assemblies. You can just see over here we have different assemblies over here in the Civil 3D, and you can create it also. You can see the basic assembly, basic line, transition. Suppose if I'm selecting this one and I click over here, You can see here how it is coming. This is the center of your road, that means road alignment, and both the side you can see the road, the basic lines you can see, curb and gutter you can see, and you can see the sidewalk with buffer, you can see it, and you can see this is the cut fill slope, that means grading surfaces to the existing land, the existing ground. So based on this based on this assemblies, we will be creating the surfaces. So that is the creating the corridor. That is the next process. Then once you've done that, you can see here some blue lines I have placed here. These all are my section lines I have placed through my alignment stations. Means normally when you create the alignment is having the start stations and end stations. In between, accordingly how you given, the stations will be created. So I created these lines, the section lines in all the stations. Once you create that, you will be getting over here the sections. You can see here the section views. Using that sections views, we created the sections in all the stations. So you can see here in 50 how the sections will be. This is the corridor sections there. Like this, you will be getting the sections in all the stations, and you can see your corridor, and you see this line, this is represent your existing ground. This is the existing ground. From the existing ground, now the corridor is created, or the road is created over here. So that means this is the cut area. So this is the way we will be doing it. So you create the surface, then from the surface you have to draw the alignment, and based on the alignment, the profile and the design profile you have to create it. Then the sections you can create it. So these all the things will be coming over here: the survey terrain modeling, alignment and profiles, then corridor and the road design. Then after this, you can see here the grading and earthwork. The grading and earthwork, somebody is asking anything? Just mute your mic. Okay. Then the next one, grading and earthwork. Grading and earthwork is basically creating grading for plots, ponds, embankments, cut and fill. So let's say I'll just show you one example here, which I already created for a pond. See, this is that same surfaces what I have created. Initially I created one surface, right? That same surface it is. Then in this side I have created the grading surface for the pond. You can see that. I'll just show you how the grading surface we created. You can see here the pond. I just select, right click, select, and you can just go to the object viewer. So you can see here how the pond is created. So that means I have an existing surface over there. Based on that existing surfaces, we have created the pond over here. So you can see the pond. So once you create this one, then later you can find the cut and fill from that. So go to the analysis and you can see the volume dashboard. So here you can see the cut and fill value. Let's say here that means I selected here the different what we can say, yeah, different surfaces, different comparison surfaces. The first one, pond with water level. So I have created the water level from top of the pond 300 mm down. Then we have found here the cut and fill. So you can see here you have less cut and more fill over there. And the other one we have done here, pond with yeah, you can see here the existing ground with pond. So that cut and fill also you can see over here. So fill is more and cut is less, and you can see the pond and just vice versa. You select the font and you select the water level. So when you select the water level and the font, that means two ways you can see. I just wanted to do the cut and fill based on the pond and the water level. So if I'm selecting water level is my comparison surfaces, then the cut and fill means just opposite it will be coming. So here I select, this is the one I created. So normally we do it from here, create new volume surface, then you have to give the name for your surfaces, and you have to give here what is your base surface. For example, I select my base surface as water level, and I'm selecting my comparison surface as pond. Then we click here OK. So you can see that accordingly it is created over here. You can see the surface one. So you can see what is the total area and what is the cut, what is the fill, all this informations you will be seeing over here. So this is the way we do the grading. So grading is one of the important tool to do the earthwork. Then we can see over here the next one, we have to discuss about the pipe network and utilities. So that means your normal stormwater, sanitary sewer, and then pressure network. This is coming under the pipe network and utilities. So in Civil 3D, we have already the pipe network and the pressure network. Both are different. Pipe network is there and we have the pressure network also. So so we have to select here the pipe network. You can see here. So again it is coming based on, so to do the pipe network you should have the surface and you should have the alignment, you should have the corridor and the corridor surfaces, all these things you will be having. Then we have to create the pipe network also here. So you can see here this is my structure and this is my pipe. So that all we have to define first. Before you are doing this drawings, you have to define what structure you required, what type of pipe you need, what the dia of the pipe, all these things has to be predefined. We have to define it first. Then you can use that for the pipe networking. And currently this is the done drawing, but when we do the new one, first we need to assign all these things. And Civil 3D is providing you some junction structures, like some are there by default, but we will learn how to create our own junction structures, and that means inlet and something like that. All the structures we will be the junction structures, the inlet. So how to create this one, that is coming under the part builder. So we will learn that also, how we create it. So part builder is almost same like 3D modeling. Suppose if you know the AutoCAD 3D, it will be little bit easier. It's not exactly the AutoCAD 3D, but some features in AutoCAD 3D we will be incorporating over here. So once you've done this, then later you can take the profile. This is the same profile what we have seen over there, but once you do the pipe network, the pipe network also will be added into your sections. This is not section, this is the profile. Pipe network will be added into the profile. It will be added into the sections as well. Then you can see over here the next thing, pipe network. Then the next one is plan productions and documentations. The plan productions and documentation is basically like how you create the plan production and documentations. That means you have to select your let's say, we'll see here, I'll just take an so basically see here now, this already what we have discussed. We have the alignment here. You can see the alignment name is Maple Road, and you have the poly lines for both the side to define the road left and right side. And so basically this is the line. There is no surfaces, the line is created over here. And you can see here also, this is this is also Maple Road, and this is the one here we have one more, and you can see that that is the alignment Oak Road, and you can see here this is our pipe network. So all these things we have done. So normally we know that infrastructure project, in the sense it will be it's cover a huge area, not like building project, right? It may be in meters and kilometers. So how can you set all these things in a sheet? So for that we will be creating over here as a view frames. You can see that, you can see over there the view frame which is already created here, the view frame here, like this you can create. That means I divided here up to here, one I have to place in one sheet, and from this is which is coming inside, that we need to place in another sheets, and this in another sheets, like this. So this is called the plan productions. So once you've done this, normally we do that from the output, and you can see here you can create the view frames. In this case I already created the view frames. Then you can create the sheet out of it. So when you click the sheets, I'll just click here next, create sheet. Okay, so you can see automatically the sheet will be generated. How many view frames I created, that many sheets will be created over there. I have created 5 view frames over there, that all the sheets also created here. You just simply click and you can see how it is placed on your sheets, both plan and the profile. So we don't want to set the same way how you do in AutoCAD one by one. We don't want to set here. You can use this plan production method, and in one click all these things will be placed on the sheet. That plan profile will be coming. The section also you can use, you can do that. Is the different method in the sense you have to select the drawing with section, that's it. Method is same. So anyway, normally the plan will be very big. So to do that plan, to do that one, we will be normally creating the view frames. You can see this view frame options in output, and you can create it, and you can create you can create the sheets. So basically what we need to understand now, I just simply given you the idea about how the Civil 3D software is working, but Civil 3D is very in-depth software. It's very wide software, very in-depth software. So we have to learn that in proper manner. You have to learn from the point till the plan productions, the step by step you have to draw. Then the corridor, in the sense, not only the simple road, you have to create the cul-de-sac, you have to create the roundabout, you have to create the road with medians, like different methods we have to focus over that. So it will be very in-depth training what we will be giving. And the other thing, we have the BIM incorporated with the Civil 3D. How the BIM is incorporated with the Civil 3D? What is meant by BIM? BIM, in the sense, building information modeling. That means you build something based on informations. So initially we were using this BIM concept in building. Now it is coming to the infrastructure also. In infrastructure we use the Civil 3D software, and we have Infra work software also, both BIM Infra work. Both software is having the BIM capacity. So basically in Civil 3D you can incorporate the BIM features. So BIM is having the different dimensions, like BIM LOD. We say that different dimensions and different LODs. LOD means level of detailings, or level of development, you can say. So normally the consultant drawing, contractor drawing, the difference between the consultant drawing and contractor drawing. So when it comes to the contractor drawing, more details in terms of model and in terms of details, in terms of information, should be provided in the contractor drawing. So normally the consultant, they will be practicing on load 300, and contractors drawing will be load 400, and as-built drawing will be load 500. This is the same concept like how you practice on the buildings, but the workflow will be entirely different because we are using the Civil 3D. So the workflow, how you practice this BIM in Civil 3D, that will be entirely different from how you practice from the building. And the BIM is having different dimensions also. What does mean by different dimensions? That means normally when you do the drawings in 2D CAD, we just simply call it as a BIM 2D. Correct, right? Sorry, not BIM 2D, normal 2D drawings. This 2D drawing is also coming under the LOD, but that will be coming under LOD up to 200, LOD 100, LOD 200. But when it comes to the LOD 300, it should be a proper 3D model. So this BIM infrastructure 3D model we create in Civil 3D. So then what is the BIM? BIM, in the sense, as I said, you can extract the informations from the model. That means once you created, you can take the quantity out of this model. You can, for example, in your infrastructure model, you have the light poles, you have the the pipe networks, you have the what we can say, the corridors, everything is there. So you just wanted to count the total length of the pipe and the fittings, and you have to count how many light poles are available over there, or you have to count the total area of the corridor, or you need to count you have to take the concrete volume. So these all the things you can do in Civil 3D using the pay item. That means you have to incorporate with the pay item file, then you can do all this thing. Like this, the BIM features also incorporated in the Civil 3D software. So basically this is all about the Civil 3D, and the Civil 3D is having the integration with the Infra works, Revit, Navis work, GIS, etc. This Navis work, in the sense, it's a clash detection software. So once the model you created in Navis in the Civil 3D, you can take that into the Navis work and you can find out the clash detection, especially your utility services. You have different utility services over there, so maybe there will be a clashes. If there is clashes, that you can find out from Navis work. So Navis work is basically we use for the coordination and the clash detection purpose. So this is the way why we have to use the civil 3D. So you can save the time with dynamic and parametric design update. What is this dynamic and parametric design update? Dynamic and parametric design update in the sense, for example, you create a surface, then you create an alignment, you create the profile, you create the corridor, everything you've done. Later on, your surface point has been changed. That means your surface is having some changes. So when you change the surfaces, accordingly the remaining all will change. You don't want to change everything one by one. So this is called dynamic approach or the dynamic update. So once you change one, all the corresponding things will be changed. And reduce errors by maintaining data consistency, support BIM standards for infrastructure project, improve collaboration between surveyors, designers and contractors. So these all are the main important, or why we have to use the civil 3D in infrastructure project. These all are the answers. So this is all about the civil 3D software. So if you have any queries, any questions, you can ask me now. No one is having any questions?
Yes, could you... Hello?
Yes, tell me.
I'm inquiring, you didn't show us, you didn't take us through the integration part, like an example, the way you did on the other parts.
About what?
The beginning parts, the integration bit, like an example, you integrating from the 3D to maybe Navis works or...
No, that is another software. Like Navis work is entirely different software. So I just given you an information, so you can take this one into the Navis work software also, like for the clash detection purpose. That is not part of the civil 3D. The one you created in civil 3D, that later you can use in Navis work. That's it.
So which means there's no that integrator between the two. Like we can be working in the civil 3D then.
Yes. So Navis work is it's
no
a different software. So normally how the procedure, Navis work is a common software. You can take the building file also into that. You can take anything, any 3D files you can take into the Navis work for the coordinations and collaboration purpose. So if you want to do the civil 3D one, you have to create a complete civil 3D model, then you can take that into the Navis work. This is the way you can do it. So no other questions from anyone related to the civil 3D? Yes.
Hello.
Yes.
I want to know about the quantity takeoff in the civil 3D.
Yes.
We talk about this one or not in the discuss?
Yeah, it is there in the course. So normally the quantity takeoff, you have an options over there. I did not do that completely, but I'll just show you an example. See, this is my corridor. Then I have to just take the total area of this corridor. So basically how it is working. you have to create the pay item file. Then you need to assign this pay item file into your, you can see here the QTO manager. Using this one, in this QTO manager I already imported one pay item file. So how to create this pay item file, how to set the formula, that we will learn in the class clearly. So but just understand the procedure. You have to take the pay item files. Once you select the pay item file, you have to assign this pay item file into your element or the 3D model, like into the corridor or whatever, the surface or corridor or anything. You have to assign the pay item files. So normally, let's say if you are selecting the corridor, you can see here in corridor, you can, I'll just take the codes. You can see over here all it is asking you the pay item file. So certain pay item files I have already assigned over there. The pay item, you have to assign it. All codes, links, top. Yeah, see here I have assigned this 1700005. This is my, based on my pay item file. So first you need to prepare the pay item files, then you have to assign it. Once you assign this one, then you can, so same like this, you have to assign for everything. Then once you assign this, you can just simply click on the Takeoff, then you click here compute. So automatically the Civil 3D will be calculating and computing, and it will be giving you the total. So I assigned only one pay item over there, this 1700005. This is just a code, it can be anything. And I assign for the corridor top, and the total area of my corridor is coming over here. So this is the way we have to create the quantity, I mean pay item. It's called the pay item files. We have to create the pay item files, then you need to incorporate with your 3D model, then you take the quantity, all the quantity will be coming. So everything is possible over there, but it has a proper procedure. That's it.
Yes, but how accurate is the
That
the
will
thing?
be
How
100%
accurate is the
accurate, because it's your surface is accurate, your quantity also will be accurate. It's based on your surface. When you create the corridor, your corridor is created accurately, your quantity also will be accurate. Quantity is just extracting from the model. So model is accurate, the quantity also accurate.
I have a question here. You didn't touch the bridges part. I'm seeing something like bridges that side. You didn't touch it.
Yeah, bridges in the sense just to create the rails, bridges, that is also coming based on the, see the procedure is almost same thing. You have to create the alignment, you create the surface, you create the alignment, and based on the alignment we have to create this thing. So everything is based on your surfaces, and so many other tools are there. In this 1 hour sessions I cannot explain everything, that we will be covering in the class. So currently I'm giving overall idea about the software.
Hi. This course only include the Civil 3D, or it's include or related the BIM BIM softwares?
BIM softwares in the sense BIM integrations, how the BIM integrated with Civil 3D, that we will do. No other software. BIM is not a software, right? BIM is a concept. So that concept we will be incorporated with this Civil 3D.
Yeah, the Civil 3D for the pipe network, it's part builder is very important. So
yeah,
nowadays people are using Inventor or something like that. It's included in the course, or?
No, Inventor is not included. See, because this all are different softwares. So when you really work in the market, the people sometimes it is easy for them. If they know the Inventor and the Civil 3D, they just create an Inventor, then they can take into the Civil 3D. But you can create in Civil 3D itself the part builder. So basically we learn about the Civil 3D software, we will be learning about the Civil 3D only.
Okay. Is it possible to bring the from CV3D and Revit?
Civil 3D to Revit, you can just export as a DWG file, then you can take into the Revit. But normally we are not doing in that procedure because Revit is for the building, Civil 3D is for the infrastructure. So normally we don't do that. But if you want to do it, it's possible. How it is possible? You have to convert, this you have to convert as a DWG file, 3D DWG file, then you can take into the Revit, you can link into the Revit. That's only the possible method.
Okay, because I want to make, when we finish in the CV3D and import it in the Revit to make design like that, so that I can make in a video like this. That's why I'm asking you about that.
Okay, so if you wanted to take it, it is possible, but the Civil 3D file directly you cannot take it. You have to convert that Civil 3D because Civil 3D corridor, it won't work as it is in the Revit. That's different software. So what you need to do, the Civil 3D, from the Civil 3D you need to convert that into an AutoCAD 3D, then you can take that into the, that means you have to convert that into DWG 3D files, then you can take into the Revit.
Okay, thanks. It's okay.
Okay.
Thank you. Yeah.
So which other whatever can it interact with? And any BIM software can Civil 3D interact with? Because he was talking about maybe exporting it to some other software for maybe some visual artistics and
Okay, so we are short of time, so see you then all. Thank you.